everybody, here we are, 7.4, parallel and perpendicular lines. This is our last part of chapter 7. And so a few notes to start us out. So parallel lines have the same slope, m, but different, no comma, but different, y-intercepts. So it's like the old joke, parallel lines have so much in common. It's a shame they'll never meet. So they never meet. And so here we have two parallel lines. Line 1 has a slope of 2, rise 2, run 1, rise 2, run 1. And line 2 also has a slope of 2, rise 2, run 1, rise 2, run 1. This seems to have an intercept of -3, and this seems to have an intercept of +2. And for our perpendicular lines, a little more notes. So perpendicular lines. Perpendicular, there we go. Lines have, let's say, intersect at 90-degree angles. So that's this part of the drawing right here. Let me highlight that part. So it's not just that they intersect at some point. They don't just kind of like cross like that. We are looking for a 90-degree angles, 90-degree angles where they intersect like this. So all of these would be 90-degree angles. And let's see what else. So that's one thing. The next part, they have opposite reciprocal slopes. I'll explain that in a second. And the product of their slopes is -1. And I'll explain that as well. So what I mean by they have opposite reciprocal slopes, we'll notice the slope of this line right here. So the slope of line 1 is 2. So M1 equals 2, the slope of line 1. And then the slope of line 2 right here, so M of 2 equals -1/2. So it's like this 2 is like got a little invisible 1 there. It's like we flipped it. So we flipped it, that's the reciprocal part. And then the opposite part is it's not just 1/2, it's -1/2. So they've noted this down here at the bottom as well, that you have the opposite reciprocal. And they also noted this last part, the product of their slopes is -1. So if I'll show you that they seem to have done it as well. If we have 2/1 times -1/2, we would get -2/2, which equals -1. So if you multiply them, the product of our perpendicular slopes be -1. So parallel, same slope, perpendicular, opposite. So if one's positive, the other one's negative, and reciprocal, you'd flip your fraction. So let's do a few questions. We're going to use all of the tools that we have now to solve these questions. So state the slopes of the lines that are parallel to and the lines that are perpendicular to each linear equation. So we're looking for, I'm going to draw it as PA, that's like parallel slope, and I'll show it as PE, perpendicular slope. So we need to find what is the slope that is parallel to y equals 2x subtract 5. So our parallel slope. We need the same slope. Remember our m right here, y equals mx plus b. 2 is our slope, and so parallel to that is just 2. And perpendicular to that, we need the opposite, so it needs to be a negative. So if you imagine a little 2/1, we need to flip this, so it needs to be 1/2. That's a reciprocal, and it needs to be negative, so -1/2. Let's do the next one, B. We need to, or I would say there is a way that you can see from general form what the slope is, but I'll encourage us to change this to slope-intercept form and then solve it from there. So we want this y by itself, and we want it to be positive. Let's start by adding 4y to each side. So now we got a 3x subtract 3 equals 4y. Now we want the y by itself. Let's divide this by 4. Divide both of these by 4. And now in our slope-intercept form, we have y equals, that's gone, 3 over 4x, subtract 3 over 4. And now we can do our parallel slope. Just needs to be the same slope. Our slope is 3 over 4. So our parallel slope is the same, 3 over 4. And our perpendicular slope is going to be the reciprocal, so 4 over 3, and the opposite. This is positive, so our perpendicular slope needs to be a -4 over 3. So not so bad once you get the hang of it. Let's do the next one. It's already in slope-intercept form, so that's helpful for us. Our parallel slope would be just the same, -1 over 4. And our perpendicular slope needs to be flipped, so 4, or 4 over 1 if you want to show it. And it's negative. Our original one was negative, so now becomes positive. You could write it as just 4. And our last one, I wanted to include this. It's a little tricky, and we just need to think about it for a little bit. So here we only have a y. I'm going to move it to slope-intercept form first. Well, not slope-intercept form. I'm going to move. I want our y to be by itself. And I'll show you what that looks like. I want to add 7 to each side. So get 8y equals +7. And then let's get this y by itself. So divide by 8, divide by 8. And we're left with y equals 7/8. So what does this mean? This means that if we had, a graph like this, y would equal not quite 1, but it would look like that. It would look like a horizontal line. Okay, and as you'll recall, the slope of a horizontal line, let me do this in another color maybe. Horizontal line equals 0. Okay, so the same slope to make it parallel would just be 0. It could be, up here, the slope is still 0, it'd be parallel to our horizontal line. And then what about perpendicular? What would a perpendicular line look like? Well, if this is a horizontal line, a perpendicular line would look like a vertical line. And what is the slope of a vertical line? As you recall, it's undefined. So that's a tricky one, but I think certainly one worth knowing, certainly one worth thinking about, and I think certainly one that shows a kind of sophisticated understanding. So pay attention to those ones. Let's do some more. There's a couple ways. Let's just move on. Identify whether the lines in each pair are parallel, perpendicular, or neither, and explain how you know. So let's investigate. Looks like we got a couple of slope-intercept form. That's great. Let's look at the slope. We've got a 3 here, and looks like here we got 1 over 3, and it's negative. So I would say this is perpendicular. Oops. because the slope is opposite and reciprocal. Or you could say, or, 3/1 times -1/3 equals -1. That's like another way to prove that. If their products equal -1, that's another way to show that these are perpendicular lines. These ones, I think it would be easiest to compare if we have them both in slope-intercept form. So let's do that. Let's convert each of these. So we want the y on one side. Let's move the 2x over to the other side. Let's subtract 2x from each side. We'd have 4y equals -2x plus 5. Now we want to get the y by itself. Let's divide by 4. Divide by 4. You're going to divide each of those by 4. So you get y equals -2/4 is the same as -1/2, -1/2 x plus 5/4. We can just leave it like that. So there's our first one. And now let's convert our second one. Let's move our y over so that it's positive. So we got -2x equals 4y plus 1. Let's move our 1 over. Let's subtract 1 from each side. -2x subtract 1 equals 4y. And now we want the y by itself. So let's divide by 4, divide by 4. And it's looking promising, isn't it? It looks like we'll have y equals this -2/4 is -1/2x. Subtract 1/4. And so you'll find we have, looks like, same slope, but different intercepts. So parallel because same slope. There you go. Okay. And if you found that it was neither of those things, well, then it's neither. Let's do this next one. This is what I started to say for the last question, but it wasn't for this question. It was for the last question. It was for this one. There's two ways, or, often there's kind of like multiple ways you can approach something. So I can show you each way. I think we have time for that, and I think it's good. So write an equation of the line in the form y equals mx plus b that is perpendicular to each line, or this line, and passes through the given point 1, 4. Okay, so we want it to be perpendicular. So we're looking for, y equals, we want the opposite. So we want it to be -1/3. So instead of 3/1, it's now 1/3, and its opposite, it's negative now. So we're looking for a -1/3 plus b. So we want it to have the opposite reciprocal slope. I forgot our x right there. And we can solve this. Now we know two of the coordinates. We can input those coordinates into our slope-intercept form. So the x goes into the x and the y goes into the y, and we can solve for b. And that's one way that we can solve this. So we can go 4 equals -1/3 times 1 plus b. So the moment we're just solving for our intercept, that's the only part of the equation we don't know. Then we would get 4 equals 1 times -3 is just -1/3 plus b. We can move this -1/3 to the other side by adding a third to each side and adding a third to that side. And then we would get b equals 4 1/3 Or I would show this honestly. Sorry, I got cut off. I was saying we could show it as 4 1/3, or I like to show it as an improper fraction because that's often how we see our y-intercept in fraction form. So 3 times 4 is 12 plus 1 is 13/3. Okay, and then we're going to combine all of these things. Now we know y equals -1/3x plus 13/3. Okay, so there's one way to do that. I'm going to show you another way. And the other way is that, well, we have a slope and we have a point, and so we can use slope point form. I mean, ultimately, they want us to put it into slope intercept form, but I want to show you this way as well. Sometimes it doesn't specify the way that it wants it, so it might make sense as well to use slope point form. So remember, that's y subtract y1 equals m times x subtract x1. And now we can go y subtract our y1 is 4 equals our slope. Remember, we need the perpendicular slope, so it's going to be -1/3. And that's x subtract our x1, which is 1. And then we can get rid of our fractions by multiplying by 3 on each side. This whole thing's going to be multiplied by 3. We get 3y subtract 12 equals, I'm going to distribute inside while we're at it. So -1 times x and -1 times -1. So we get -1x plus 1. And now let's go to slope intercept form. That's what it wants. So that's what we can do. Let's add 12 to each side. We get 3y equals -1x plus 13. And now you can kind of see it taking shape, kind of looking like our other line. We're going to divide by 3 on each side. And then there you have it. Y equals -1/3x plus 13/3, the same as our other one. So 2 different ways to do it. Might make sense sometimes to use this version, might make sense sometimes to use the other version. So that's up to you. And then let's do a couple of these last ones. I just want to do them quickly because I do have some of the textbook questions. And I do these in a particular way. There's a couple ways to do it as well, but we're kind of setting up equivalent ratios. So the following slopes, following are slopes of parallel lines determine the value of n. So we want these to be equal. So if we have a slope that's rise over 1, 2/1, it equals n/2. So there's kind of 2 ways you could do this. I could think, okay, these need to be equivalent. What do I got to do to 1 to make it into 2? What do I multiply it by to get to 2? Well, I times it by 2. And what I do to the bottom, I should do to the top. And we would end up with 2 times 2 is 4. And so 2/1 should equal 4/2. And therefore, n should equal 4. So is it, you can check, is it true? We can put it back in our original. Is it true that 4 divided by 2 is the same as 2? Yes, it is. And then there's another way to do these. I tend to like to do them that way, but there's another way that maybe you'll remember our very first unit when we had to do a lot of cross multiplying and dividing. We want, remember, these are parallel, so we want the same slope. So -3, I like to set it up as fraction or ratios. -3 equals 6/n. And what we can do here when we cross multiply and divide to solve for n, you cross multiply the 2 that are numbers and divide by the third one. So if we go 6 times 1 divided by -3, we'll get n. And 6 times 1, 6 divided by -3 equals -2. So n should equal -2. And then let's see, does that seem to make sense? Does it seem to be true that 6 divided by negative 2 gives us negative 3? Yes, that does seem to be true. And let's do a couple more. So the following slopes are perpendicular now. Okay, we're perpendicular. So what we want, we're looking for, we need to remember first about the opposite and reciprocal. So we don't just want to set these up as equivalent. We want to flip this guy and make it negative first. So we actually want a negative 1 over 3. Remember, this is over 1. That is going to equal r over 6. So we've got to flip that first and make it negative. And now this might be a good time to, ask yourselves, what do I need to do to 3 to make it into a 6? I got to times it by 2. Let's do the same to the top. So, negative 2 over 6 equals negative 1 over 3. And so therefore r equals negative 2. And this last one, I'll do the cross multiply and divide way. First, we need to, this is our slope right here, we need to make it into a perpendicular slope. So we need to flip it, so 5 over 3, and we need to make it opposite. Our original one is negative, so our new one has to be positive. So 5 over 3 equals r over 9. And here we can, now to solve for r, we can cross multiply and divide. So you multiply the two that are diagonal numbers across from each other, and you divide by the third one. So if we do 5 times 9 divided by 3, we should get 45 divided by 3, which is 15 equals r. And then you can check at the end, is it true that 15 over 9 is the same as 5 over 3? Yeah, indeed it is. So we know that we did that one correct. Okay, thank you so much. I'll let you know what textbook questions I'd like you to do.